and thank you for inviting me here to speak about DataLad. Cool. So we're going to speak about the context for this workshop. I prepared for 2 hours. I'm not sure if we want to split it up or we'll see how it goes. So whenever we get tired of listening to me, then just stop me, please. and then I'll just run through a few practical aspects, and there I'll give you the link to the environment that we'll work in, and then we'll start. So the context is we have a research team, and Alice is a PhD student in this research team, and she works on a fairly typical research project, which is collecting data, processing it, and eventually publishing it as well. And it's a cumulative process, like we all know. So from the first time you collect data to the point where you convert it to some other form of format, to processing it locally, to processing it together with other stuff, to the final result, it happens continuously. And you go back and forth between versions. So the question is, how does she go about her daily job, specifically when it comes to data management? So when she works locally, she uses things like Git, like we just learned, to be able to see this is a file, this is where it originated, how and when did we make a change that resulted from version A to version B, and why these things were done. And if she doesn't share her work with other people, it's still useful, then so you can go back. There's always this thing about be kind to your future self, which Git is helping a lot with. Some other thing that's useful to know is we often make large changes to our scripts, our work, etc., etc. So there's all these big changes, and they go back and forth between taking a part of that version and taking a part of what someone else developed, putting it together, and knowing how to navigate through this is quite useful. Yes, we want to be able to go back in time. So this is local version control, and we do it with Git, as we just saw. Is that blurry? It looks very blurry to me, or my eyes just... Okay, my eyes are screwed. But she doesn't only work on her own, she also works, and she also doesn't only work locally, she also works on different setups, so on the server, on a laptop at home, at the desktop at the office. And we obviously need a useful way to synchronize everything across these environments. And some of it is done by other colleagues. So maybe they're in a consortium and there's a group that they collaborate with in a different country, but also collect data. So you want to be able to know, oh, this part of the data came from that source, and trace it back to them and any changes that they made. So this is the distributed version of version control, where you not only track your own work, but you track it together with other people, similar to what Cyril showed with forking, for example, and merging changes from various sources. So she applies local version control for her own work. She also applies distributed version control with colleagues and collaborators. And then when it comes to data sets, it's often useful to keep data only when it's needed, when and where it is needed. So there should be some source for a data set, some true source, like this is the full data set, but you might have something on your laptop, you might have the full data set on the server, and you might want to rotate the files as you use them. So you don't necessarily want to download 2 terabytes of full data set if you only want to use one subject's data, for example. And right at the end, we want to be able to publish this because open science, yay. Raw data, converted data, processed data, final outputs, and then eventually how do you get to the figures that you publish in your paper? And you might want to publish this completely or selectively. So you might want to publish the derivative data, but not the raw data because it's identifiable, something like that. So this whole process is generally what's referred to as data management or research data management. And we're going to see how we do it with DataLad. So DataLad is an open source software package. So it's open source. You can expect all the code in the code base, and it's also free. You don't need to pay for it. It's not free in terms of time, so you need to invest time in order to understand it. That's probably the biggest cost. But you can install it on all operating systems. So we run it on servers with Ubuntu. We run it on Windows computers, which is admittedly the more difficult one to run things on, and then also on Mac. And you can install DataLad, the Python package, with pip quite easily. You can also install Conda, or depending on your system, which installation version you use. Okay, so we're going to get to know DataLad, and we're going to follow a similar process to what Cyril went through with Git. And Git is also a very important part of DataLad that you get to know. So if you want any more information about the background of the content or the content of the workshop, there's a link. If you want to follow these slides, there's a link for that. This is the one that you will need to go to now. So datalad-hub.inm7.de. So this is where we're going to work, actually, everyone. So I pre-installed essentially everything that you need to use for the workshop, so that we don't have to spend the first hour installing everything ourselves. If you're interested afterwards, we can do that if you want. And then it's going to be a step-by-step. Let's execute this line, etc., etc. So you need to sign in. Log in using the email address with which you registered for the Brainac. So the one that I sent the emails to now. Use that email address, and then you can select the password, whatever. But remember the password. So it takes the first password that you enter. If you have trouble, just tell me, then I'll reset your user. I think it requires 7. Yeah. So 1, 2, 3, 4 doesn't work. 1, 2, 3, 4, 5, 6, 7 works. There. I think I have 1, 2, 3, 4, 5, 6, 7. I'm not sure. Is anyone having trouble that I can help? Sorry? Okay. It should open up something that looks like this, or it might not be with a dark background. It can be with a light one as well. Your email address. My own. Yeah. Some people have multiple email addresses. And then you get like super safe password. Yeah. And then I'm not, so Melanie, I'm not checking the chat. If Grant was. Okay. So it's pretty cool. The thing that the cloud compute environment that we use to set it all up on, it's a EC2 instance of AWS. If anyone is interested, we have like a write-up of how to set it up for a workshop. And it's not a lot. I think it gives a lot of compute power, and it's like $1 an hour or something. So it's more than enough, more than we need for this workshop. Okay, so now we're in a Jupyter environment. If you're unfamiliar with this, you can tell me. but it's like Jupyter Lab. You can code in Python. You can open a terminal, etc., etc. You might be seeing this view. So if you open a notebook, it's the standard Jupyter notebook environment, and it's whatever, so that you can execute Python code. But we're not going to work in a notebook, discard. We're going to work in the terminal. So you can immediately open the terminal. So if anyone is falling behind, please just shout and I will stop.
You open the terminal, not the, did you open it?
Terminal, yes. This one. So not the console, not the notebook, the terminal. Okay, so let's start. Let's get cracking. So we have in the slides, we have code, what do you call it? Like code blocks, and you can always copy the code. So it's useful if you want to, if you can open the slides on your own computer as well. Otherwise, you'll have to type all these things, which is also fine if you want. But I have step-by-step code blocks that we are going to execute. So the first thing we can do with DataLad is check the DataLad version. So DataLad -- version. And then they give us this message. It is highly recommended to configure Git before using DataLad. Set both username and user email configuration variables. And you already did this with your own systems, right? With Cyril, so you can do pretty much the same. I have copyable code, but it does give you the DataLad version, which is 0.17.9. Anyone having trouble getting the DataLad version? Nope. Cool. So if you want to know more about DataLad after you've installed it, you can say DataLad help. So what we're doing is we are using the command line interface of DataLad. DataLad is a Python package, so you can use it via Python as well. But we are using it via the command line. And we're also, how do I hide this? Show left sidebar. There it is. Okay. But there it says DataLad comprehensive data management solution, blah, blah, blah. DataLad commands create, save, status clone, get, push, run, diff. So you might recognize these from Git. They're very similar. And I'll explain a bit more about how it relates soon. And if you want to know everything about the DataLad installation itself, often when you create an issue, when you use DataLad and you have a problem and you create an issue on the GitHub repo, we ask for information from DataLad WTF. So if you want to exit the DataLad help stuff, you can just press Q for quit. So DataLad WTF, and then it gives you a lot of stuff. So it tells you the version, it tells you dependencies that's installed, which environment. It gives you DataLad extensions, and we will work with one of these extensions. So DataLad extensions are additional software packages that you install on top of DataLad that help you achieve more things. That's a very high level thing. But anyways, we've installed I've pre-installed the DataLad container extension. And there's Git Annex, which is a very important part of DataLad, and I'll explain a bit more now. But the point is here, you can basically inspect everything about the installation by typing DataLad WTF. Okay, so the Git identity, it's important to configure your Git identity, so I would suggest doing that now. Since previously you did it for your own systems, this is a server, so it's completely unrelated. So just if you want to get your Git identity, it gives nothing because it's not configured. So to configure it, you can copy and paste that code, but replace my name and my email with your own. I'm going to look at your hands, and if they're stopped with typing, then I'll continue. Okay, 10 more seconds. Okay, so like I said, DataLad is a Python package. So you can use it via the Python API, and we can open up IPython here if it's installed. I must check. Yeah, it is. So if you type IPython, it opens up a Python interface. So again, this will interpret Python code. So if we then say import the DataLad API and we create a data set, very simple instruction, then it does something. Right, so you don't have to, if you don't like the command line interface and you just want to work with Python, you can use DataLad. But this workshop is with using the command line interface. On which side? Okay. Oh shit, shouldn't have done that. Is that better? Why is it not? How do I increase this? Okay, that's the biggest I can make that. No, it's the reveal, it's the slides. Yeah. Yeah. Okay, cool. So, and then we can just type exit to go out of the IPython prompt. So that was just a quick way to show you it's usable in Python, and it's written in Python, but most people actually use it from the command line. So this is an explanation of what we are going to work with. This is kind of the base unit of DataLad is a DataLad dataset. And a dataset is what you define it to be. So it could be your folder with your MP3s. It could be a full bits dataset. It could be a directory with a single file or subdirectory upon subdirectory upon subdirectory. So you define what the data is. But DataLad, if you run DataLad create on an existing directory with file tree, it turns that into a DataLad dataset. And what that means is it uses the two main tools that DataLad is built upon. So DataLad is like a convenience layer on top of Git and on top of Git Annex. So think of it as version control for data. So you have version control for code that most people are familiar with, and you use Git and use GitHub and you publish your scripts and stuff and you make changes, etc. But we want to be able to do that for data as well. The problem is that something like Git doesn't work well with large data files and many data files. So we could, for example, have a few terabytes. You cannot push that to Git repository, but you might want to track it as you do with the Git repository. So what DataLad does is it uses Git for the version control part of it, and it uses Git Annex for the large file storage and access part of it. So essentially what you do when you create a DataLad dataset is you turn the full file tree into a Git repository so that you can track changes to all the different parts of the data set. And you add an annex to it. And an annex means that it stores all the data in that division, right? And there's a link between the annex, which has all the file content, and the Git repository, which tracks the names and the locations and the states of these files. So whenever you have a DataLad dataset, there could be a file in it, and that is essentially a symbolic link to where the actual data content is. So when you have, for example, a DataLad dataset, let's do open your datasets. Wasn't it that one that I saw? Or whatever, let's just do this, right? So here you see a data set, but it doesn't have all the data, right? It has this thing which has an arrow on the file. And when you see there, it's .git annex objects and the hash of the actual file. So this represents a symbolic link to a location. It's like the annex key to a location where the content is kept. So you have the metadata and then the actual data. And the cool thing about this, like practically, is I can put my data wherever I want. When you get the DataLad dataset, internally it knows where to find that data. So the dataset is perhaps like 1 terabyte or 2 gigs or 500 megabytes, but the DataLad dataset that you download is like 1 megabyte. So it is a full file tree. It looks as if you have the full dataset locally, but you can get the files you want if you have access, for example, to that server via the DataLad interface. Right, so that is what happens when you create a DataLad dataset. So let's do that. So if you go back to the terminal and you say DataLad create, and here we use a configuration. So you can create datasets with multiple configurations. And there's the whole chapter on that on the handbook, the DataLad handbook. But we're just going to use one for now, text to Git. And this means all the text files in the dataset are committed or saved into the Git repository, and all other files are going into the annex. And so you have all these different configurations that you can specify. So this is not to mean that you should use this as default. Maybe the text files contain information that you do not want to put in the public Git repository. So don't use it as default. This is just an example. And we call our dataset bits data. Right? Then it does something, blah, blah, blah. It created an empty bits dataset. So if you go here, you'll see there's a new folder called bits data. Cool. Does anyone want to have a DataLad dataset? Command B, okay. Then I can go into it, cd bits data. You can auto complete here with tab if you want. Just make it clear. And I can list everything that's inside here. ls-la and inside this location. So you'll see there's the standard hidden directory links. There's a .datalad, there's .git. So it created a Git repository as we did previously, but it also created the .datalad. And that is a few configuration things that specifies this is a DataLad dataset. Cool. So what you get with the DataLad dataset is you get version control, same as you did with Git. You can essentially use Git commands here interchangeably. So I can say git commit to the DataLad dataset. It will pick up that it's the same as DataLad save, for example, which I'll explain now. It's called DataLad save. So when you start learning it, it's a bit confusing because we just use save, and that is an add and a commit together. So let's do version control. Similar to what Cyril did before, we're gonna write some. We're gonna create a README file, and we're going to put some text into that. And there's a very simple thing. We echo a markdown string into the README file. So now when you list the contents, you'll see there is the README file. And when you do cat README, it will show the content of that file. A bit structured data set for my input data. So again, if I'm going too quickly for anyone, just stop me. Please feel free to do that. Okay, so now we can check the status of the data set. So this is similar to Git status. So we just do DataLad status. Status. So now it tells me this is an untracked file, right? We made it, we created the file, we didn't do anything else with it, it's untracked. Cool, but we can now save it. So we can say DataLad, I'm just gonna copy. DataLad save, and the -m is the same as with Git -m message, and we add a save message. So this will do the add and the commit internally together. There you see there's an add and there's a save.
What's the reason, what's the decision behind baking them together? Since clearly Git wants them to be separate, but you made a different decision here.
Yeah, so I'm unsure. Like I didn't make the decision. One of the other coders did it like probably like 9 years ago or something. And I'm not sure. Maybe it's just a convenience thing. Like so then you would expect it to just be a save. That's my guess, but I'm actually not sure. Okay, so now we can do further modifications. So let's add more content to that README. And you can save again. So this is the local version control setup, right? So you create a file, you add something more, and you save it again. So again, it added the change to that specific file, and did the save again. And then finally, you can check the history of that file with git log. So we don't have a DataLad log, we just have the git log. But like I said, you can use anything that you want to use with Git, you can use with a DataLad dataset as well, because it is a Git repository. And there you will see few initial commits. The first one is create a new dataset. So this is done by the first create. So when we create a data set, it makes a commit initially. Then it makes a separate commit for the configuration that we added. So instruct annex to add text files to Git. That's this -c text to Git configuration. So basically it just adds more historical information that's useful to know. Then this is the commit we made initially to add a README, and then we add more information to the README. So this is the same Git log that you get from any Git repository. Yeah, sorry. If you only want to see the latest one, git log -1. Cool. Now we're going to start talking about data consumption and transport. So similar to Git, we have, or let's say with Git, you have a git clone command. So if you have a repository that's somewhere hosted online in public or private, you can say git clone. Now you can do the same with DataLad clone. And say we have a repository that's a DataLad dataset that's, for example, shared on GitHub as this dataset is. We can say DataLad clone that dataset. Then it gets it. It does the same as a git clone. And then when we need specific files, we do a DataLad get, and we get that file. So when I said earlier, Alice, the PhD student, was working, and she doesn't want to download the whole data set when she only wants to use one subject's data, Now, in this case, you clone the DataLad dataset, which is the Git repository, which contains a file tree of the full dataset representation, but not all the files. And then you go to a specific location. You say, I only want this. Then you say DataLad get this. So this is what we're going to do now. Okay, so now we go one level up. So outside of our bits dataset. So we go cd one level up. Then we do DataLad clone. And we're going to clone from a also an MRI dataset, so something we collected in our group a while back. So it's called Study Forest. It's a lot of scanning of people while they watch Forrest Gump, the movie. So now it's cloning. Blah, 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 blah. Install OK. Hopefully that works on your side too.
Why does it say this warning there?
Which warning? There's obviously a lot. There's failed to access. Blah, 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 failed to access, blah, blah, blah. So what DataLad does internally is it is the DataLad dataset tries to clone it from various sources. So it has what we call siblings. It could be hosted anywhere. And when it tries to clone it to your dataset, it checks if there's availability from various sources. And if it doesn't get it, it's fine. It gives the output message that but it still is able to install it from at least one of those sources. Okay, so now we've cloned a dataset. Now we have a DataLad dataset. Now we can go back. Now we can go into that dataset and we can list the content, and then you will see you have all the stuff, right? It's a bits data, kind of looks like a bits dataset. Participants.tsv. There's a folder with code. There's a lot of subjects and there's a lot of JSON sidecar files. Cool. So we have all of this. Let's check the dataset size that we have now. So we type du.s/sh. It's 19 megabytes. So this is obviously not the actual data. That would have been much larger. And we can check that actual size by doing DataLad status -- annex. So what is the status of the annex of this dataset? And this will tell us something. 2,389 files, more or less 13.5 gigabytes. So that's the actual dataset size, but it's not here locally. So this is what I've said already. The DataLad dataset is just the Git repository, i.e. the metadata of all the files, and also the files that are committed to Git. So if we use this text to Git configuration initially, when you clone the dataset, it will get all those files that are committed in Git to your local place where you cloned it. Okay. Does anyone have a question or a comment?
Maybe you could mention that you would wonder why is that useful maybe in the first case. But for example, let's say I want to, like there could be different use case for this. For example, on OpenOR, there are lots of data sets. I want to look for content in OpenOR, like I want to look for data that's with motion correction. What I can do is I can actually do this type of cloning of data sets or even of all of OpenOR, and then I have all the text information there. And then I can simply search with, for example, a grep and say, tell me which data sets have a motion somewhere, motion files somewhere in there. So sometimes this can make it easier to search, or if you have your own data set, instead of looking through folders, then you can, for example, look at things easily. I mean, if you're in the terminal anyways in on Linux and you have the data only locally, that's relatively easy. But if you're then, for example, on Windows, it would be super easy to have just the DataLad folder like this present, and you don't even need to have the VPN because there's no content, there's no actual data shared. So I have my file tree here, so I can look up stuff even if I'm not in on the server.
Yeah,
I see that I was just browsing through your files, just also to reiterate, after I see the next video in get, but it works like any other stuff. So let's say I only want to download all the T1s from that repository. So once I got my data upload, I can do, wildcard. So star dot this are only my page files. I don't care about ephemeral.
Yeah.
From that repo, so then you can look at other people's data, say I'm open euro, but only select I'm ephemeral, I'm
Because OpenEuro does not have a search API itself.
It has a search API,
Yes.
but I don't
But
think it's as good as there, and you still have to then you have to go into data sets. So there are like 100 different data, I mean, there are thousands of data
You
sets.
still have to click on it, it's a search within, you can't do an overall.
I mean, you can, for some, it's search for keywords, but it's nowhere near as good.
That's not what I'm saying. What you cannot do, get me all the pet data for this guy, for this data set. This is what it does, because you clone the tree and you say, in that tree, I want only the pet files, and we download only the pet files.
Yeah.
Which you can't do
This is
with
actually the next
an actual data.
the next command is the DataLad get. So in this case, we can retrieve actual file content, multiple files. We get all the files of subject one for all the functional rounds of the localizer task. And we do that by specifying specific path, but then using a wildcard wherever it's necessary. So DataLad get and point it to a specific file or to a specific directory and get everything underneath that directory, etc. So here we just do that. Oh, sorry. Yeah, that's good to know. I need to remove that comment. So I have no idea where that data is coming from, but I'm getting it, right? So I didn't have to log into some place that is specified beforehand because that is the location where I need to get it. I get the DataLad dataset and I run DataLad get and it gets me there. And if that place requires password like access management, then DataLad interprets it like that and asks you for a password. Right. So if for example, one of the data sources is on a server on the in the hospital network or whatever, and you have access to that, then you just type it in when DataLad asks you, and then it will get that content for you. So that's also why it's nice to share the DataLad dataset, even for people that don't have access to the server. So they can see what the data looks like or the structure of the data, but they cannot get the data itself if you don't want them to. All right, so it got multiple files. And then when you don't want to use them anymore, you can drop them. So in this case, we can say we can drop a specific file. So if you copy and paste that, then it just says drop. Okay, so that file is now not located locally anymore, but it's still somewhere else. If you're dropping it from the only place where you have the data, then DataLad will ask you, are you sure this data is not in a different place because it knows? Are you sure you really want to drop this? Then you can force it to drop the data, then it's completely removed from the data set. So that's something, there's some safety built in.
We mean DataLad keeps track centrally of all the forking and all the getting.
Yes. Now of all, not of all the forking and getting, of all the siblings. So that's a separate concept. So I will get to that.
Because it would be pretty weird if you kept track of all the downloads.
Correct. Yeah. Yeah, that's no, it's not what's the word? It's completely unrelated, or not unrelated, it's completely diverging from the concept of this distributed control. So you have a clone, which is a complete working functional setup of the data set that knows where sources of the data is, not where other clones are. Yes.
Can I ask a question? Can you hear me?
And then you can just get that file again if you want. The nice thing about dropping and getting is it saves storage space. So storage space is costs a shitload, and people handle storage space as if it just exists. But obviously, it costs money. It costs environmental influence, and when you start running these large scale analyses on clusters, that's when it gets really useful. So that's when system administrators will start liking you. If you then use DataLad clone, get the data that you want, do the analysis, drop everything afterwards. And then you do the following step. And you can parallelize this, that only what you need for a specific subject is run, and you only get that data. Then the working space that you need is like 1 gigabyte versus when you do everything for the whole data set, it's 20. Cool. Okay, so let's talk about dataset nesting. And this is very nice feature of DataLad. What you can do is link specific versions of datasets to each other. And we call this nesting, and we have this hierarchy of super datasets and sub datasets. So if you, for example, publish a paper, you can link it to an analysis which is a different dataset of a specific version of a specific commit, which in turn has a sub dataset of the pre-processed data, which in turn has a sub dataset of the data, the raw data that it came from. So you can track this route back to the raw data that came out of the scanner, and you know exactly which version of the raw data went into process state, which version went into the analysis, and which version went into the paper. Because we all know that setup where you're like, but I changed this subject, I excluded, is this the one analysis what was done on the excluded one or not? And then you're like, oh shit, I need to redo it with another set of the data or subset. Now DataLad formalizes this with the nesting concept. And again, you can always revert back to these things and track this history. It also helps with scaling. So when you have large data sets, we, for example, so say we have a BITS data set and it has 20 subjects. That's very easy to track in Git in terms of the file tree, but when the file tree becomes really large, so like the Human Connectome project, Git starts struggling with big data sets in terms of the number of files. So when it goes over 100,000 files per Git repository, it becomes very slow when you, for example, clone that repository. So that's when it's useful to break them up into pieces. So we have a DataLad dataset of the Human Connectome project where we have a dataset per subject and not a dataset for the whole thing that includes all the subjects' data. So we do dataset per subject, and they are all sub datasets of the Human Connectome project dataset. Okay, cool. Infinite, yeah. I mean, there's something that you can do, and there's something that's recommended to do. So it's not recommended to do all of that levels of nesting, but it's possible because yeah. Yeah, so there's no limit. It's more the limit of human interpretability. Like, when do you know where you are in this hierarchy? Do you need to know if you're a certain space? Yeah. Okay, so now we're going to nest some data sets. So now we're going back to our BITS data set. So we go out of this one and we go cd BITS data. Right. So just to recap, we're in the BITS data set that we created initially, and we have a README file there. So there's nothing else. We are going to do dataset nesting. So the way we do this is pretty similar to what we did before. We clone the dataset, but now we give it an extra flag, which is the -- dataset, or only single dash with a D. And we give it a place where to put it, right? So if you copy and run this code inside the BITS data directory, it clones some data. And what we're doing here, we have DICOM. It's just functional MRI data that's in DICOM format, and it's a GitHub repository that's published publicly. Now it added a bunch of stuff, and you can see also it added Git modules. And Git modules is a Git concept and it registers sub-modules of a repository. And that is like the analogous concept of sub-data sets of a data set in DataLad. So if I now go ls-la, I think there should be like that, then you'll see we have the README file. Oh, let's just do normal ls. We've previously had the README file. Now we have an inputs directory. I think you should be able to. No, we don't have the tree command. That would be nice. And ls inputs raw data. There's license readme dicoms tsv file dicoms, and there's a bunch of dicom files. And again, this is a clone, so it doesn't have the actual data. It's just the DataLad dataset. And the fact that we added this flag dash dataset, it told DataLad to clone this new dataset as a sub dataset. And what we can do now, oh, we're going to clone another one. And this is a container. So I'll speak more about it. Just copy and run that code. After you've done that, you can run DataLad sub datasets. And it gives you what we just did. We have two sub datasets of this dataset, and they are located in inputs raw data and code containers. Should it doesn't autocomplete for new commands. It just autocompletes the history of what you've typed. Yeah, that's something that we can set up, but it doesn't do that now. Okay, so we have a data set that we created. We added a README file, and now we've added two sub data sets to that data set, and there are specific versions. So what we're going to do now, this is a summary image of what we did. So the reason I'm showing this is that it's a very useful way to track your own projects when you do analyses, right? So you have, it's useful to separate the things into modular units. So you have your analysis, you have your input data, and then you have a new data set that encompasses these two. So here we have inputs, which is in the form of containerized code. And we have an actual DataLad dataset with some data. In our case, we have DICOM data. Now we've put them as sub datasets into a new dataset. And now we can go ahead with the next step. And we're going to talk about computational reproducibility. And the question there is basically, the one that we want to answer is, which version of which script was run on which version of the data in order to produce which version of the results. And this is something that you do not want to have to answer by manually trying to retrace your steps. If we can use the machine to do that for us, that's perfect. And it's good for reproducibility for other people, because they can inspect the machine readable code to see this version of the input data, this version of the code, this version of the output.
There's only one result, the correct one.
The one gets published and never retracted. So DataLad has a specific command for that. It's called DataLad run. So you say DataLad run, and you give it inputs, the code to run, and where to save the outputs, for example. And then it links all of these together using git commit, the specific git commits that all of these states are in. And then someone else can, or you yourself can just do a rerun, and it automatically uses all of that machine readable provenance record essentially to do exactly the same. So you can computationally reproduce the same result just by one command and not having to know where the input data, etc. was. We have something that's very similar. So run and rerun works for like scripts that you have locally or that you clone from a repository or something. But often you don't want people to have to install the software locally in order to run it. So we used containerized code for that. So on this server, for example, we have Singularity installed, and the alternative is something like Docker. And it creates an image of the exact operating system, installed packages, all the versions, and maybe the code, or maybe you give it code from externally, such that you can run this virtual process without having to install everything locally on your machine. So it's like a virtual machine, but it's from the command line. And we have this extension called DataLad container, which gives us the capability of capturing provenance records from code that was run via a containerized solution. Does anyone have a question about this? Nope.
Yes.
Yeah.
One, I'm executing my scripts.
Yes. There's an example that we'll get to, but it's like, so you like myscript.py or whatever. And then you have a command that, for example, runs it from the command line, like Python-m run your script. And that is that's that string you put into DataLad run as an argument.
Can you run with software that's not open source like MATLAB if you have it locally installed?
Yes, it is possible. There's some peculiarities to it, as always, but it is possible. There's also, for example, you have to have a license for free server.
Yeah.
So there's all of these things that you have to link locally, as in addition to what you would normally do with the DataLad run command.
Visibility in a container can certainly we might have the container.
So we're going to do this. We're going to, for this specific computationally reproducible command, we're going to use a container to run some code. And you can see which containers you have installed or registered with the data set using the extension command of DataLad containers. And it's called DataLad containers list. And we do it recursively because we want to list all the containers that are registered in the data set and all its sub-data set. So there's a lot, actually. So there's a bunch of containers, and they're all there because we installed this sub-data set code containers. Is that why you're frowning?
No, I'm not. First of all, I'm not frowning. I'm just. So this was the installation we did with the sub data set. That
Yes.
Became
Yes.
part of that data set. No, okay. I'm
Exactly.
trying to connect the dots.
No, that's cool. So if we go to this location where we installed these data sets from, this data set, which contains a lot of containers, you see it's a DataLad data set. I don't know where it lists all of the stuff. I think all of these. Yeah.
And these are just useful containers.
Yes.
You have.
Yes. So repronum, reproducible neuroimaging.
Yeah.
A group of people that care about reproducible neuroimaging, and they maintain a lot of these things. So containers and ways to convert code from DICOMs to convert data from DICOMs to bits, etc., etc. So it's a list of useful containers. Okay, so from these, we will use the repronum-repro-in container for DICOM conversion. So if you remember, we have the bits dataset. We included the sub dataset, which is DICOM data, raw DICOM data. And now we included the sub dataset, which is the code in containerized code. And now what we'll do is we'll do the containers run command. And you can, what you see here is we have DataLad containers run, that's the main command. And with a message called convert subject to bits. And then we give it some arguments. So the container name is the one that we'll use. The input is where we find the raw dicoms. The output is where we put everything that comes out of it. And this is the final command that we give to the container. So this command would be specific to the container, right? So this is not something that relates to DataLad in any sense. It's just that by giving it to DataLad, DataLad has the capability to capture that exact command that was run, such that it can rerun it in future. Or if people want to inspect the provenance record, they can see what exactly was done. Okay, so now I would like you to run it. So you copy that, paste that, and we run it. It will take probably some time because it needs to download the container. Luckily, it's not a large container, so it's 300.
Hadn't we already downloaded it? No, we hadn't downloaded the container.
Yes,
We
yeah.
had-
So it's doing a get. So it did that clone, and now it's doing a get when it actually needs that container.
I thought that the get was not done before.
Can I ask?
Yeah.
while we're waiting, what is the container?
So there's a nice way container virtual blah 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 blah. There's a nice image somewhere. I don't know if they have it here. This is yeah, and this is not the exact image I'm looking for, but it's similar. So if you want to be able to reproduce code or the software installation environment or the actual operating system, you use some form of software. And you can interact with that software either graphically or via the command line. And these are often the solutions that people work with. So something that people are very often familiar with is something like VMware, or I don't know, even know this weird stuff that's used. But if you want to log in remotely into some system, you have something that some IP address or something that you go to locally, you log in and you can see the other screen. It's remote desktop setup, right? So this is the entire system and it's graphical. And I don't know what it says here, but it's like a virtual box or blah, blah, blah. Remote desktop setup. So then you're actually working on your remote setup. If you want to do things via the command line and you only want to reproduce the same environment, then you use virtual environments. So I only want to, I have a Mac, you have a Mac, she has a Windows machine. She installed something with Python version 3.9 and it's DataLad version 0.17.1. And she created a virtual environment. There's a configuration for that virtual environment. She shares it with me. I install exactly the same, but I install it on the Mac. She installs on Windows. There's still some things that can cause discrepancies. If we don't want to have that operating system level discrepancies, we use containers. The container creates an image with the full operating system, all the software environments, but then you use it via the command line, as we did just now. We don't see this visual representation of the other machine. Is that sufficient?
Yeah, that makes sense. Thank you.
Cool. Okay, so the run command, the containers run command finished. Now we can see what changed, right? This is just like, it could be, we just clicked buttons and something happened, but what really happened? So we can do a DataLad diff, which is similar to a git diff to see the difference. And we do head minus, or yeah, it's still the one. So the difference between the current state and the previous commit, right? And this is what changed. So it literally tells you everything that was adapted, added, files that were added, etc. Here you see that is a symlink. And all the other files are files. And this is because DataLad has now added these files according to whatever the dataset configuration was when we created it. We use the text to Git configuration. So all the text files, which is text, TSV, JSON, Python, blah, 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 they go into the Git repository. And the .nii.gz, it's a binary file. So it is a symlink. And this symlink is a symbolic link to the annex content. So I'm just saying that to reiterate the concept of how DataLad differs between what goes into Git and what goes into the annex.
Because if we push this now, then clearly the need.js would not go up.
Correct.
Right? It
Yeah.
would only be on our local computer.
Yes.
Assuming we would do this on
Yes.
our computer. Right, all the other files. So I didn't understand that also, that I thought when you said text, you only meant .text.
Oh,
You
no.
actually mean all of the files. Which
Yeah.
are text files.
So basically you have, the main distinction is text-based files and binary files. Binary has all this, like when you open it without a specific reader, then you have all this weird shit. And text-based file,
Binary, weird shit. Makes sense.
yeah,
But it's been the config at the beginning when we done DataLad, we said with configuration. So you could say in your config.
put everything into
I
annex.
want only, I don't know, .r to be pushed. And
Yes.
.txt, .pd to stay
Or
local.
file size, you can also specify as a
Okay.
discriminator.
You to specify what you want.
File size seems to be
Yeah.
a useful one.
Yes,
as well.
agreed. And then you can see git log -n1. And this is a very useful thing to look at. Oop. I have enough, yeah. And this is called the provenance record, which is also just the commit message. So what DataLad did is that it took the stuff that we put into the containers run command and it formatted that into a commit message that is machine readable. Right, so whenever we say DataLad rerun and we point it to a specific commit, so this commit hash, this one, then it will take this message, it will parse it, and it can see exactly where the inputs are, what the command was, where the output should go, and it can rerun this whole thing. So this is called the provenance record, the commit message of the run command, the same thing. So it puts that into the Git history.
But this is what was actually shot to the terminal. No.
Parts of it were given to the terminal, yes. So here you can see extra inputs. Oh no, wait. Yeah, extra inputs. This is where our this is our container. That location container name goes into extra inputs. The dataset ID is the ID of this the dataset that we're working from. The command is this part, which is the same as this command. And the inputs raw data dicoms, it's come from there. So it takes all of these things, it puts it into a standard format that DataLad understands and that it can reinterpret when it's needed.
And that standard format is actually the BITS provenance record. So associated with BITS, the referencing project has been developing how you can make this XML, well, originally XML-based chaining of commands, so you can have whole pipelines written in a way that are understandable and you can reproduce the code in it.
Yeah.
So for example, the human connector program, they have all this provenance of what they have done, right, from collecting data to converting to every single step in that processing.
Provenance, which is not yet. With instead of a JSON, you have a JSON LD, which looks exactly like this.
Sorry.
So LD is simply just a slightly different version of JSON, but it becomes executable. So machine could take the JSON LD and apply those commands and just rerun the stuff. which means you can pull a derivative data set, say your data as a process or your data, and then execute it directly without like within the JSON.
So yeah, it's basically when people start talking about the extra benefits you get with machine readable metadata, this is what the type of examples that we think about. But it is quite, if people have a presentation on metadata, it's quite vague, like, okay, whatever, like I can add metadata. But on a very low computational level, this is what it means, and it can be reinterpreted. So for example, in 10 years time, someone can go, okay, these are all the run commands that happened for this data set. Say there's 10 of them. I only want to use everything up to level 8. I want to discard all the rest. So I can go back to that. And then I want to fork my own analysis from that point. And all of this can happen in an automated way. I don't have to go and click and point and think and email the person, etc. This can very easily happen in an automated way on a server, where you just give it a couple of commands to know where to point the data set to, which commit, etc., etc.
I mean, this is a stupid comment, I suppose, but like so far, like this means that the source data has to be well maintained, safe, and secure. Because if somebody goes in and starts changing the source data here, then everything breaks down, right? Like if I want to reproduce this 10 years later, 2 months later, or something.
Sure.
We talked about taking it from a server, like from the hospital server or something.
But that is
How does it work then? Like if I want to reproduce and I'm clearly somebody changed something in the source data, how does the warning message, will it just?
no, but
the
the point is that you have version control, right? So if the source data is version controlled, and you give it into a run command like this, the source data, the commit, the specific commit of that version of the source data is linked to the run command. So whatever changes in the source data, if that original commit still exists somewhere, which is a necessity for any analysis, like if I analyze stuff with pen and paper, the source data also needs to exist. Then at least with that commit, which is uniquely identifiable, my analysis can still rerun in 10 years time if that commit and the related data still exists, irrespective of what happened to that source data afterwards, because those would be new commits.
But what if you somehow manage to modify the source? So that commit is itself now not the same thing. You have a hash, right? So secret would be like,
Yes.
oh, this is not. So you said this commit is this, but you look at the hash and you're like,
Or it doesn't, someone erased it.
Hash, something has changed.
Yes.
So
Yeah, then it will error out.
you would just say,
But that is the same, even if version control as a concept didn't exist.
I'm not saying that DataLad should fix that problem. Because
No,
it's an unfixable problem. It's just want to put a pin in like your source data, be it on the NRU server, whatever it is, it's going to be very important because
yes,
often one problem
Yeah,
in
but
academic setting is that the source data get changed and updated. So
Exactly.
new administrator comes and says, "Oh, I want to add this instead," and then all of a sudden somebody forgot to pay for the server. And it goes, these kind of things.
yes.
But that's exactly why the raw data folder that Klaus has shielded is only accessible at NRU to a very select few people.
Yes.
And people cannot screw with the raw data. And that would be the same as with the DataLad source data set.
Yeah.
You would keep it like this and no one can basically touch it. You can read from it, you can pull and do shit on your own machine.
Yeah.
And then if I believe in your derivatives, maybe I allow you to put it in a perfectly pre-processed folder. If I don't believe what my student does, I'm like, I'm not putting the into the derivatives folder.
Yeah, but, okay. No, I was wondering when that happens and clearly it fails, like I just wondered how it fails, like what kind of error message does it give, what does it say?
Yeah, I mean, it would be,
trackable is it? Because I mean, I used to be in academics, I think this could happen so often,
Yeah, yeah.
it would be important to know how it looks when the source, when
Yeah.
it's on me.
But I could try and fake it, DataLad rerun.
Maybe this error is not discussed.
Bad revision. So it might not be a very helpful error message because it doesn't automatically assume that the data is gone. It assumes a general problem and it gives a general thing. Like it cannot find this revision. Then you as the human would have to start investigating. Okay, what does that mean? Yeah. Okay. So now we created the data set, we added a README, we added sub data sets, we ran an analysis, and now we have outputs. So we can say ls, there's the input data, there's the source data, there's the code, and we have subject 2, which was generated by the run command, containers run, and a bunch of other files that also committed there, right? So we've built up this data set over time now, and we might want to publish this. And this is the second part of that image that I showed before. So we have stuff on GitHub, we cloned it, and we got the data, we analyze it. Now we want to push it somewhere. And this is again where the concept of a DataLad dataset being the annex and the Git repository comes in handy, because you can split up these two. You can push the metadata wherever you want in a public way if you want, and the annex to another place where you want to keep it secure. And you can keep it secure. You can push it to a place where you as admin have access, and a select few people. You can publish the metadata Git repository on GitHub where everyone can see it. Ah, okay. So for OpenEuropid, they have these data sets. It's cool. I can find these things. Let's do DataLad get, and then it fails because I don't know access credentials, which you want because you want to keep it safe. But if you do, then you have access to it. But the concept here is, let's do a DataLad push to publish our data. And DataLad is integrated with a lot of stuff, anything that can handle a Git annex backend, let's say, or if it's just that it hosts the Git repository, that also works, and then the data itself goes elsewhere. So this is also what we're looking at for OpenEuropid. Like it could be that the data sets themselves are hosted on GitHub or via catalog, but the data goes to some cloud service that you want to use. Some people use AWS, some people use OSF, whatever. And in our case today, we're going to use Gen. So Gen let's go to that. So I would like you to go to this. It stands for, I think it's German something neuroscience. Modern research data management for neuroscience. So it's a German thing, but you can use it. It's openly available wherever, and it has a similar interface to GitHub. The cool thing about Gen itself, it's integrated with Git Annex, so it has Git Annex running, and it's also an open source thing that you can install locally on your service, for example. So you can run your own Gen instance. But I would like you to register and create a user for this. And this so far is the best DataLad compatible solution for putting lots of data on for free. So if you don't want to put your stuff on OpenEuro, but you're still fine with putting it in public, and you don't want to have limits, go to Gen. Like you can put gigabytes and gigabytes, possibly terabytes of your data there, and just have it. And it's DataLad compatible.
No, we talked about, maybe you said this, but there are like now different rules between the EU and the States, so where we can store our data.
Yes. So
You
this,
said it's German.
Yes.
So yeah, okay, so it should be, it's like big share versus.
whatever is anywhere else, yeah. So this is a nice. So if your data protection officer is the only problem with putting it on OpenEuro is because it's in the US, then put it on Gen. That's fine. The nice thing is it doesn't have hard. We haven't at least tested the limits of how much a data set can be, what size. So it's really cool. But I wouldn't build your own complete data hosting solution on top of it for a whole institute, for example. Unless you want to run your own Gen instance, then it's a great idea. Anyway, so please create a username for that. And we're gonna have to create and upload an SSH key, which is a bit of a mission, but let's do that.
And the question is, should we, because, so we're getting started lunch here around 12, so question if we should
Ah.
wait and start with this after lunch.
We can, if the timing is fine for the rest of the day. I don't know how it works.
Is the lunch, when is phone starting at 3, right? 2, 8 o'clock, so 2 o'clock. Yeah, so then we would have a full hour after lunch then.
Yes, that's
Yeah,
fine
fine.
from, yeah, that should totally be fine.
Then why don't we go for lunch now and then you can create this when we come back so that we have one to basically.
I like lunch.
give
Create
time.
what?
Yeah.
I would say get it to send the email now though, 'cause it takes a while to get through the NRE.
Well, I sent it to my Gmail, but yeah, let's send the email now.
Cool.
Pass through the capture.
Yeah, I did that. They took me 3 times. So just, I don't know why. So maybe it's something with the Germans, you know, they made it very specific for the Germans that we cannot really see what's going on.
How is it going?
Granville, we're gonna go for lunch and then start again at 1 o'clock, but can you follow so far?
Yeah, it seems to work out great. The only thing is I don't know how to ask questions, but I can maybe just send Pontus a message or something.
You can write in the chat and I can monitor it. I
Perfect,
just
I can do that.
you're muted.
All right, no worries. Okay, that's perfect.
Or you can send Pontus messages.
Yeah.
Cool.
All right,
We'll
great.
break, but I leave the Zoom room open.
Okay, but then you'll be back at about 1 o'clock.
Yes.
All right, perfect. Thanks so much.
Where's a good place to put this?
Just there. Don't you think that's better?
Yeah, but I'm gonna click and then it's gonna disappear. I think you should rather,
Yeah, tell him to unmute.
Yeah, don't worry about it. Don't worry
yeah,
about it.
Granville, if you have a question, just unmute yourself and shout.
Okay,
And
but
if you type in the
you mean
chat,
the room, isn't
I
it going to
think
cause like
generally
feedback with the
people see it, yeah.
computers? Is it going to cause feedback?
Okay. Where's more? Hide floating. Yeah. Okay, we were at Gen. So does everyone have a Gen account? Has anyone added an SSH key?
No.
Okay, one person. Okay, so let's do that.
Do we do that also in the web thingy, or do we do it on our computers?
On both. Well, no. So we do it not on. Well, you do it in your browser on the web thingy, but also on Gen. So if you're on the web thingy, you might see this thing. Server unavailable. Just restart. It will reload whatever you did up to that point.
Mine just disappeared. Is that a problem? Do I do it all to start?
If you log in again, it should have maintained everything you did before.
Yeah.
You clear your console.
Okay. Yeah.
So you can go again to datalad-hub.inm7.
Use clear the console. by mistake.
My laptop.
Cool. It was Command B, I think. Command B. Yeah. Okay, so open a terminal. Okay, so you have a Gen account and you can log into your Gen account. There's mine. I should actually delete this repository because I tested this beforehand and now there's already the repository with the same name. So I'm just going to delete this one. That's data set, I think it was it that's data set or best data? Okay, cool. So this is what Gen looks like. There's a dashboard. You can create repositories. You can look at issues, etc. So it's really similar to GitHub. It has Git Annex support as well, and that's useful. So there you can create new repositories, open etc. But now we're gonna upload an SSH key. So you go to your settings and you go to SSH keys. And there you can see I already have SSH keys. We can delete all of the stuff because I don't want anyone else to use my stuff. But now we first have to generate one. We'll do that from the terminal. And I posted the link in the slides on how to create SSH key. So we go directly to the instruction for Linux or Linux or Linux or whatever. So use this command. So essentially it's SSH-keygen space -t and then space ed25519, which is the format with which we create the key, because you could also have the algorithm rather. You could also use the RSA algorithm, and then your email address. So if we do this, and I put in my email address, generating private public ed255 blah 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 key pair, and now you enter a password for this key. So whatever password you want, just remember it.
Do we have to do this for each repo at Gym, or do we have to do this once when we establish the connection between
Yes,
computer
once when you establish connection between your computer and Gym.
my own computer, I redo it.
Yes.
Like, or I go to another.
Yeah, correct.
So what do we need to type in here?
Oh, sorry, this is not the password. This is a file in which you need to save. Sorry, don't. Has anyone typed in something and pressed enter?
Yes.
Okay, then press Control-C, so you cancel the whole thing. And then just retype or just press up and then enter again. And you just press enter. Don't do anything because it puts it in the default location. And then you enter a passphrase for the key, right? So whatever you want to choose. And enter it again. And then it creates some stuff. Now I have a key pair, SSH key, with which Gen will recognize that when you push something there, it is you. And we cannot push, Gen is set up such that we cannot push the annex content to Gen without an SSH key. So you cannot push it via HTTPS or another protocol. So this is a bit of a specific workaround that we're doing for now. It's not something that you should accept is generally always like this. And now you can check if that actually worked. So you can write, oh, sorry, you need to copy, you need to add it to your SSH agent, which is locally maintained. So firstly, we need to start this thing. So you need to run this eval SSH agent is, and it will respond with some process ID. If anyone has trouble, just stop me. And then finally, you add that key to your SSH agent. So that now you need to enter the passphrase that you chose. Cool. So now in this location, you will find this key file. And the way that you can copy it is, let me just see, what's the other link that I posted? Just give me a second. No, there's a cat. Come on, I think it's in this. Uh, Let me just copy that. I just want to check something quickly. Oh, that's my private key. Don't read it. I'm trying to figure out what I should do. Sorry for the. I did put it in the slides, I think. Why not? No, I didn't. It should be in one of these.
You said create and upload. There's like another upload.
Yeah.
Upload is doing DataLad, and that's just like how to add it then on Chin. So then on Chin we go add. Public elements of your public key file. So that should be fine, right? We just go on the Chin website, we say add a key, then we give it a name like, I don't know, it's data.
Yeah, but the part that we should copy, I just want to quickly check how. I forgot how to.
Or how to make the public key.
Yeah. There was a command.
That it's above, when it's generated, it's above. It's basically the same ID than .pub. So if you just go back.
Back to what?
So if you guys have you have your SSH key generation, and after you've entered your password, it says your identification key has been saved, blah, 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 and then your public key has been saved in same path.pub. And it's that file that you need to basically add and copy into your Chin.
So is a cat and then that is it .pub?
.pub,
Thank you.
that one. And
Okay. This part you copy into Chin. Thanks,
you
Melanie.
just copy from your terminal over the other. So I have Chin open here. And I just say add SSH key. So I'm under my profile settings, add SSH key. I just give it a name and then I take this whole line
Yes,
and put it in there
including
Key name.
into content.
key name. You
So
can
that's
just
our key name.
Including the email address.
yes.
Uh,
So key name, just whatever. Like I don't know.
it's data,
Brian Mac.
add, or whatever.
Content is like that. So after you did the cat command, you just copy everything that it printed and you put it into the content, and then it will add key. You press add key.
Yes.
Yeah,
Right? And then it's like this.
Yeah.
You can copy it directly over to your browser.
mine is super long.
Oh yeah. IRSA. So we need to copy that part. So highlight that. You already have some other RSA.
Can you give me? Yeah.
Yeah, I accidentally used the second link.
Yeah, no worries.
This one.
So that is the private key that other people should not be aware of, and the public part is the yeah.
I cast into it.
Oh, so you didn't. I understand what you mean.
Yeah, I didn't take this. I took.
Okay, so you should copy the whole thing. Yes.
Yeah, okay.
So
It's
just
just longer
layers.
because it's RSA.
Yes.
Anyway.
Does anyone need help? Okay, cool. So this is just the background setup. Now we can do the actual stuff that we want to do.
But again, we do this once, so.
Yes.
When we have this established on our account, it should be fine.
Yeah. So let's create a new empty repository named bit data in your Gen account. So go to dashboard wherever, and you click on this create a new repository. So call it bits data, bits-data. You can make it public. So it doesn't have to, oh, sorry, you cannot make it public yet. It needs to be created first. So all Gen repositories, new ones are created as private, and then you can set it to public afterwards.
You cannot unclick that.
No, not at this point. And it's important that you uncheck this first box. It says initialize this repository with selected files and template. Don't do that. Because we want to have an empty one because we want to push our data to the empty one. So if something exists in a non-empty repository, there will be a difference. And then you will have to solve this merge conflict
But
stuff.
it's like when you create an empty repo on GitHub, you don't, I mean, you either want to have the readme file in there or not have the readme file in there, depending on what you did on your local.
Correct.
Right? So
Yeah.
it's the exact same thing.
So the important part is just put the license as none, and which is right at the bottom of the scroll thingy, and then uncheck this box and then create the repository. Cool. So you will see this. There's no files, there's no issues, there's no anything. It's just an empty Git repository. And now we want to add this as a place that we want to push our data set to. The important part here is you shouldn't copy this clone thing. You should copy the one up top. They're exactly the same except for the .git extension. And this is another, I don't know, edge thingy with Gen where Git Annex is not going to recognize that files are available in the annex because the clone dataset has .git at the end. So it's a edge case that shouldn't be there, should be accounted for in the code base, but it's not. So it's a workaround that we use. So you can copy the HTTPS thingy, or okay, please ignore what I said just now. That this will be useful when we want to get data from this thing. But now we're adding it in order to push data. You should use the SSH URL.
Uploading data, we want the .git. Downloading, pulling an entire repo, we want to be careful with the
Yes.
That's what you said.
Yeah. Specifically when it comes to Gen.
I don't know what Gen.
Gen, specifically with this interface. Yeah.
Okay.
This repository thingy. Okay. So copy the SSH URL. And then in the slides, we say, DataLad allows you to add repositories as siblings to a dataset to which data can then be pushed with the push command. So now you can type this, or rather copy this and then replace the SSH URL. So we say DataLad siblings add, and we add a dataset as a sibling. We add it for, we add a sibling to this dataset, which is located locally in that specific location. So that's what the dot is for. So the -d gives the instruction for which dataset are we adding the sibling. And the name of the sibling is called Gen. We can call it whatever you want. You can call it Gen blah, blah, blah. That's a user specified thing. And the URL for that sibling is the SSH URL. So this would be, here's Heunis. So you
need to be in the bits data folder, because otherwise it's going to be lame.
That is true. So if you're not in the bits data folder, this would not be a dot, but it might be a ./bits data.
Exactly.
Cool. So this is the error that you'll get if you're not inside the bits data folder. So if I change this command to bits data, then this would be fine. Or if I cd into bits data before and then I run the same command, it would be fine.
So use very slowly again. Siblings, what does that specifically do now?
Sibling is another place where the data for the same data set can be found.
That's what we're saying. We're saying
Yes.
we're copying the data, we're gonna upload it. But it's not the source, it's not the original, it's a sibling, it's like
Yes.
it's a relative of the original.
So the important concept, the concept that's important to understand here is the concept of original. The concept of original is only sensible because we as humans understand that this is where the data originated and now it's elsewhere. But when it comes to distributed data management systems or distributed version control, whatever, it doesn't really care where's the origin. It cares where are sources of the a specific true version of the code or the data or something. And that is where siblings come in handy, because the data set tracks where all the siblings are. So if you say DataLad get a file, it might try at sibling 1 first. Then it doesn't get it because, I don't know, connection, something, that server is down. Then it tries with the second sibling, if there is a second sibling available. So
Automatically it will do this.
yes,
It requires zero manual input or prompt to.
only if
parse
it
through
requires a,
siblings.
no, it requires nothing like that. It will only require input if it wants you to input your password for a server, for example. Yeah. So this is now, so I said add the sibling, and it's an SSH URL that we're adding as a sibling. DataLad recognizes this is a SSH protocol that requires a SSH key, and it's asking if we want to continue with this. And then we say yes. So just press, or you can type yes, enter, and then it continues. Yeah, so it succeeded. It gives a warning. That's a bit confusing. We should update that. Do not detect whether gen carries an annex. If gen is a pure git remote, this is expected. So it's a bit unnecessary if that is not what you're interested in. So you just want to know, did it succeed? It did succeed, but it did give a warning. And this is because we have this discrepancy between git annex, what it defines as git repo, and whether there's an annex attached to it.
You could just comment, so the reason why I not only ever want a single remote. So I guess when I'm working on my own data set and I have the NRU server, then the NRU server would be the usual remote I want to have this in. But what are reasons for having several remotes? So several siblings, what could be reasons for that?
So you, okay, let's think. I mean, it depends on accessibility for different people. For example, you want to have maybe redundancy in where data is available from. So if that server shuts down, then you don't want to have people not have connection to the data. You might want to push the Git repo of the dataset to GitHub, in which case you create a GitHub sibling. And DataLad then understands that it will only push the Git part of the data there, and the other data in the annex, it won't do anything to it. Sibling does not necessarily always entail a copy of the data. It might just be a copy of the repo, the Git repo. Yeah.
Yeah, okay. And I guess
Clone.
someone like Google, for example, like our Google Photos, they basically do this under the hood all the time because they make copies of my photos on several server locations. So they're always available and backed up.
Yeah.
And if one crashes, they still have multiple other
Fallbacks,
copies.
yeah.
Yeah, in a seamless fashion,
Yes.
so you never know when stuff goes down.
Exactly.
Like for DataLad, I would never know if I have 4 siblings, if it picks from the first or the fourth. I don't
No,
know, that's what I
it will
get.
give the output so you can see what it tries to do. And you can increase or decrease the log level such that you see nothing or you see everything. So you can inspect that, but it doesn't automatically. Sorry. Yes.
Will they sync with each other, or are they like just copied at one instance in time and then they go in different time?
So the way that they would sync with each other is based on standard version control, or distributed version control practices. So, and we're going to get to some of that, where basically I say my true version of most recent version of the data is on Google Cloud, and I clone it. So I have the Git repo. Then I get some of the data. I add to it, I change it. And now what I decide as the master of this data set is that this is the new version. Then I push back to Google Cloud, it has the newest update. But maybe there's also a sibling on some server somewhere that doesn't have that version. And then I can just push to that sibling as well. So I can go to that, check out a new branch, merge the changes, and then push to a sibling. So that is a decision that I make because I know this is the correct version. They will not automatically sync unless you have set up a job that runs automatically to sync these things.
So one example could be, I have my local data set and I have it now on OpenNeuro, so it's automatically DataLad data set, but I also have a local version. And right now I haven't made this a DataLad data set, but what I could do is actually make this also a DataLad data, or like take basically the DataLad version on, add derivatives, like add what I want to compute for my paper to it. And then only when I'm completely happy with this, I take it down and push it to OpenNeuro, so all the information to make my one paper is there. Then I work on my second paper and keep working only on NRU. And then the second paper, I can push the computational results in a second step. So that would be, I guess, the example.
Yep. Okay, so now we've added the sibling. We can inspect that by saying DataLad siblings. Ah, come on, I'm not in the dataset. That's DataLad siblings. And it gives the same warning again, which you can ignore. But it says here we have a sibling. So if you haven't added any siblings to a dataset, it always has this, because this is one sibling. This is my version that I'm working on. But now we've added Jin as well. So it's very similar to DataLad subdatasets. You give subdatasets command and it lists all subdatasets. Here you give the siblings command, it lists them. And we can push to our complete data set, meaning whatever we said should be in the Git repository and in the annex to the sibling. So we can say DataLad push, and then you need to specify the sibling by the --2 flag. And then you put in the sibling name that you chose when you added the sibling. In this case, the standard that I added in the code is Jin. And then it starts pushing. So there you see it's 49.9 megabytes that it's busy with. And this is mainly the extra, remember we had the containers run command, and then it ran some analysis and it converted data for subject 2. So it generated some TSV files and Python, blah, 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 and then the Nifty. So the biggest part is that is the Nifty file, because everything else that was in the dataset was part of a subdataset, and that contains almost no data. Therefore, it's quite small. So the biggest part of what we're pushing now is just whatever we generated from that containers run command. And then you'll see there's a copy, there's a publish, blah, blah, blah. So everything succeeded nicely. Cool. And now what you can do is you can go to your Gen. I haven't refreshed here, so this still looks like it looked before. There's nothing. And then when I do a refresh, there's my old data set. So
and can we just look, so under source data right now, under sub2, under func, it is actually a link to the Git annex.
yes,
But the Nifty is actually
available. Yeah, because the this data set is a DataLad data set with the annex attached to it. That's why Jin is nice. So it gives the Git repository and the annex data in one place, kind of. So, but when you clone this data set, it will still just be a Git repository that you clone, and you have to get specific files if you're interested in them.
Maybe another question. Is Jin similar to GitHub, but only you access it?
Jin is similar to GitHub, yes. The difference is that it's an open source project that people can run on their own and install instances, right? And it is built on top of Git Annex, where GitHub is not doing that. So with GitHub, you have a limit, the amount of data that you can push to it.
Right.
That's quite low. And there's a thing called Git LFS, Git large file system, that you can attach to your GitHub stuff or Git account that functions or let's say it achieves similar goals as what DataLad achieves. But with Gen, it's built on top of Git Annex, which is a completely different solution, but also geared towards managing large files, arbitrarily large data sets. So a Git repo, I can publish something maybe up to a Git or a gigabyte. I don't know what the limit is.
2 gigabyte, I think.
Well, how many?
I
2.
think 2
Okay.
gigabyte.
And here you can publish something that's like a terabyte on Gen.
So in terms of holding data, Jing is much more.
Yes.
But again, all our data, you would need to check
Yes.
how is this stored? Am I allowed to push it there?
Yes.
Is this certified? So Region H has some restrictions on where patient data can lie or subject data.
Yes.
Right now, we are restricted actually to Microsoft Azure.
Oh, for Christ's sake.
We could also, we're working on getting also access to AWS, only the Amazon Cloud Services. So if, or Amazon Web Services, and then, and also Google Cloud, that we're also, because we're saying, why would you go approve Microsoft, but not Amazon and Google? It's the same thing, like literally, and they're all like GDPR compatible and shit and whatever. So right now we're looking for this, but in principle, right now you cannot do this if you have not asked and registered in your data protection statement, like in your registry, in the package system, that this is accepted storage.
Wait. Is this the ethical? No, what is?
Data protection.
That's a data protection. So we always have 2 documents. We have our ethical protocol, which is that we can at all do a study like this. And then we also always, this is what Peter usually does for us, have a registration with the Data Protection Office. That's a Paxios registration. In that Paxios, yeah, that's the system they use.
Okay.
In the Paxios, it actually currently states exactly under which conditions the data is saved.
Yes, same.
And that is currently written as it's the NRU server system.
But how could you get approval to upload Moco?
Because I have anonymized. Once I
Yeah,
fully
okay.
anonymize,
Fully anonymized data.
I
Fully
am
anonymized.
done.
But how could you upload the bits to bits data sets, for example?
I have gotten explicit control. I've got explicit informed consent by the 2 people that are up there.
No, I know, but that meant that you could override the.
Basically,
So if you ask for that consent for each new study, for every participant, then you can push it wherever you want.
Yeah, it's not even that simple.
no,
Sometimes the explicit consent is not enough because it could be argued that it's not informed enough, and then the data protection officers
Because this is not
decision.
the committee that make the
No, no,
decision, it's the data.
protection officer, exactly. So the way that I wrote it, I went to the 2 medical students. I explicitly explained them what OpenOR is.
Yeah.
I showed them what the data is. I'm saying, I'm going to put your data here. Everyone can download. I'm going to cut your face out, but everyone is there. And you basically will have to do that kind of explanation with every subject.
Okay.
And then they could say, they could also sign maybe the open brain consent or another consent form. And then this would be okay. But it's our local DPO who has to approve it.
Granted, she didn't cut their literal face off.
No.
But
Just their
if
literal face.
we're doing an imaging study on human subjects in NRU, let's say I'm gonna have from Rice scan 7 subjects with Drummond. How, because that's the sample size we work with. What if we want to upload all their imaging data, defaced to Jim? Like, how do we do that?
You still have to prepare a document, data protection impact assessment, and give it to the data protection officer and wait 17,000 months. And then,
Yeah, so you still need to see, so this is actually our local data protection officer that we need to approve. We can start this process, for example, now and push them. Cyril has pushed them for Amazon and for Google.
Yeah.
But we can start pushing it for Chin. Chin should be quite easy because it's in the EU.
Yeah.
It's made by TU unit. So in principle, this whole, this is like US, blah, 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 bullshit doesn't hold.
No, it doesn't hold. But the other things, these are men in gray suits, like they can always come up with things which makes everything really complicated.
Yes.
But Kea, this was a nightmare. Like we used to realize we cannot get past the lawyers. This is impossible. For
Well,
us.
so I think we're trying to push against that, especially because we can have access control. But this also means that if you still set up the DataLad thing for yourself, you could do that in a folder at NRU, right? You could do it for yourself, and then it's basically ready as soon as your publication is ready. you can then do what I did, fully anonymized, throw all patient information away.
No, we can't do that with PET studies and fMRI studies probably either. I mean, at
And
least.
with fMRI, you can.
Yeah, okay, but so Grammel has a, well, I'm have to get back to you on this one, but Grammel has a question. Should I read it? Is that okay?
Yeah, I can ask myself if you can hear me.
For GitHub large file storage costs a lot. How can they afford to give us free storage of maybe a terabyte?
They're not widely known and widely used yet, so they don't have, they haven't reached this point where they've reached their limit in terms of space that they need to start paying more. And it's also, you often see this from like nationally funded or university systems where they put a system in place that's for free. That's also where Zenodo.
The German government?
Yeah, it is
or-
funded by the German government.
Yeah.
So, okay, so Grammel, it's the Germans, basically. That's-
But
But
granted,
the same with OpenEuro. Why is OpenEuro free? Because the Americans fund it.
yeah, actually, it's the open door right now. It's NIH funding
no, I-
Stanford to pay for the resources.
So someone is paying a shitload of money for it, but luckily not us. We'll pay in the long run when our kids cannot breathe anymore. Sorry. So now we have the data. One comment I wanted to make on what you said, Melanie, is that to bring it back to the siblings, and that's also another reason why siblings are useful, because you cannot necessarily be sure that all your data is going to be available on AWS forever, because maybe your infrastructure changes, maybe the decisions of some important person high up changes, whatever, and you want to have the flexibility to move your data around. And with the mechanism of DataLad siblings, it makes it much easier, such that you can pull from a sibling before they shut down this thing, get all the data, then create a new sibling, push it elsewhere, or maybe do that upfront already, such that when something changes because of some regulation or a fire or whatever, you have a new sibling. Okay, so we have now effectively published something that contains not only data, but also the history of this, how this data was created, and also a provenance record of how raw DICOM data was converted with a very specific container that has a very specific software operating system, software packages, and a very specific script into some output that has a very specific version. So we've answered that question, and we've published to everyone to use, so they can also answer the same question on whichever system they're using, right? The question being, which version of the data did I use with which version of the code to generate which version of the output? So this is a pretty nice place to be computationally. And this is very nice. If you can publish a paper and you publish something like this together with that, that's really awesome. It makes you feel nice inside, and it's good for science and all of those things. So now we want to see how we can use published data. So we've now cloned stuff. We've DataLad push, DataLad run, DataLad get, everything. And now we want to also see how we can then take the next step further to illustrate this kind of iterative process or cumulative process of data management. And what we're going to do is create a new data set. So go out of your current data set, make sure you're at the top level, so in your home directory, and then you do a DataLad create. And now we use a different configuration. It's called Yoda. I think it's a self-referential abbreviation, but I can't remember what it stands for. We have it in the handbook. There it is. The Yoda principles. I don't know where it's. Somewhere in our handbook, it's explained what Yoda stands for. But it's basically, we've thought about it a lot, and we came up with this set of principles that is a good idea to structure your project. So you have a structure that says we have code, we have data, and we put them all into data sets. We register them as subdata sets that we can version control all the modular parts, etc. So code, docs, environments, you have input data, you have output data, and you have a lot of extra information. So when you create a DataLad dataset with this configuration, it automatically creates this kind of backbone structure for you.
Yoda, that's not DataLad, that's a agreed upon principle.
No, it's
That used to-
someone in the DataLad group came up with the
Okay, so
principles.
Yoda is DataLad.
Yes. And
There's clearly a lot of philosophies of the best structure your.
of course,
but
yeah.
This is DataLad.
So you will see now LS, it automatically creates a few things. Oh, sorry, I need to go into CD my analysis. So it automatically creates a few baseline stuff and then wants you to add more. So there would be a code folder. All right. So we created that. Now we can clone our gen public data set as a sub data set. And this just builds further upon this nesting concept. So once you're in the My Analysis folder, you can clone it. And this is where it's important what I said about not using the .git, right? So you can go to your Gen account. If you copy the HTTPS URL, you will see at the end there's a .git, and that will cause problems. So you use the same URL, just not the .git part. So this again, if you copy it from the code that I supplied in the slide, it would be your username that's important there. And so we clone it. We clone it into the dataset, meaning this will be registered as a sub dataset. And we put it into the input folder. And now you have to enter your username and password, because I didn't set that if you haven't set your Gen repository to public, it's going to ask for password. So this is an example of how DataLad interprets the fact that you cannot just easily clone, you need to enter username and password. I have no idea what my password is.
It's password. Yeah, I know. I thought it was password.
Fuck.
Yeah, but every time.
Didn't you use the same one all the time?
It's also just the word password.
Okay,
Yeah,
so
it's
there's
not-
the typo.
That's perfect.
It's not-
It's the hacker.
They'll never think it.
Okay, so I made it non-private.
Can I assume I can't go back and see my password somewhere.
Your password was.
Now you can reset it.
But it wasn't. I don't know why it wasn't.
That was the first time we went into Jupyter.
I thought I made a password every time.
Now you can see I set the repository to public, and then I ran the same command, then it didn't ask for my
Oh,
password.
I can do that?
Yeah.
I have 2 different passwords, so I can remember the password.
Did you-
But I don't remember
But we wrote them down.
one of them.
Why did you make 3 different ones? It's just playing with it, right?
You're
Anyways,
assuming we're smart over here, man. I don't know why you make that assumption.
Sorry, Alex, I'm sticking with
I
private.
remember all of
This
them
is
as
like healthy.
passwords, but not
Neutral
what they were
table.
for.
And where did you set a public on the settings, right?
yeah, there's a checkbox. Yeah, correct. Untick private, save the settings, and then clone again. So now, if I go again, DataLad sub datasets, it will list that one called that we specifically called input, but the original repository is called biz data. And then that's the dataset. And now what we're going to do is we're going to download the script. So this is another way of how you can add stuff to your data and also track the source to your data set without having to clone a specific data set. So it will be restrictive if we only can rely on Git repositories to be part of our data sets. But sometimes there's a script that someone just put on the internet. You can locate it with a URL, but how do you clone that? And DataLad has this convenience function called download URL, which basically gives you whatever is available at that URL, that file, it puts it into your dataset and also logs the source of that URL. So if I then say, copy this, so DataLad download URL with a message, download code for brain masking from GitHub, and we put it in the code /get brainmask.py file. And this is the source. This is where it actually comes from. That this is what Adina, my colleague, prepared a long time ago and put it in the DataLad handbook repository. So if you paste this, cool. And now what you can do is you can check. Now there's also a code. So inside the code folder, ls code. Ah, shit, Stephan. There's a README and a get brainmask.py. So you can see cat py. There's the code. Some NiLearn stuff. Blah blah blah. Make a basic plot. Something something something. Okay, so it's a code to get a brain mask of a nifty image. And the cool thing is, with our data set that we just cloned into this as a subdata set, we have a nifty image from the subject too, right? We also want to run this brain masking thing, but we want to run it given a set of installed functionality that we don't have locally. And again, we're going to use a container for that. So now we're adding a container. So this is also a prepared container that has a specific location, and we call it with a specific command, given the command and given the image. And so we add this container. So it's going to download that. Takes a short while. It's 300 megabytes. It's fine.
So why that's something, so I totally understand that this is overwhelming, that you know, when you have these containers, you have this code here, you can see it when you're not used to working that way. But in the end, the goal is that we can make our analysis so modular that we can build it together with different code pieces and wrap it in a container, so that I later on can basically rerun it easily. Right now, we do this too. We run on the NRU server, free server, or SPM, or PDE lab, or PMOD. We do that right now already. The only thing is, once Klaus updates the NRU server and the underlying packages change, sometimes shit happens.
Sometimes, always.
Always.
Every single time, everything breaks down.
And if you have it in a container, you're just independent of that.
Yeah.
And I can also, if my computer gets stolen tomorrow, I don't care, because my data and my code is somewhere, I can just put it again and start again.
Yeah.
I don't need to reinstall 5,000 different programs.
But the problem I'm having now is the containers are brilliant. We should use them. But I think the biggest problem I'm having under you is like data. It's being moved around, it's being changed, it's being touched by too many people all the time.
But that's
Yes. We have the coding, all the blah, blah, blah. Like,
No, but that's why we're making, that's why Cheng has spent 6 months converting everything to bits. And we're trying to give the power for handing data out to PIs. so they
Can I
know that
quickly-
This is the ongoing process.
Is there a new thing happening in like 2 minutes?
Well, when Paul gets up.
Okay,
No.
so it's not strictly okay. Well, we're close to the end now.
Yeah.
Do you have a question?
Yeah, so would then be like the workflow, okay, I do all my analysis, blah, blah, blah. Okay, now I'm ready. Have my results I want to publish. Now I Dockerize everything and I have one Docker for this publication.
I think in the end, that's what I would prefer, that you have one Docker, obviously, where you have your whole analysis chained. I think that's the cleanest for people that want to reproduce it. Sometimes I think analysis happens in stages.
Yeah.
So that your pre-processing is actually something another student did 2 years ago.
Yeah.
They did some analysis, and then you did, and then maybe you would actually need to chain multiple containers.
Yeah.
That's possible.
Well, we're doing it now because this is the second time we're running a container. We're gonna run code via container on a subdata set that was previously generated by containerized code.
Or you reset, Mel, or you reset what you consider to be your source data.
Yeah.
The
you
source
can do
data
that.
is, because that's basically what we're doing. Like, we're considering the source data to be a very derived data state in our project. Which is not all, it's not optimal, but it is, we have to work with it.
That's true. But I agree that that's one of the things in bits, right? That we're, for example, talking a lot now about these derivatives. And if derivatives look like real data sets again, then we just start from there. And then
That's why I was so adamant about the derivatives thing. Like, I think that's a really good idea.
yeah, and Martin promised me our first week of March. He's putting it in.
Nice. Okay, so what I did now is I just ran DataLad containers list again to see that we have added this Nylearn container, and now we're going to run it. So we have input data, which is our gen data set, which previously we converted some DICOM data to Nifty data. That is now a new sub data set in our new analysis data set. And another sub data set is a container. And part of the actual data set is this thing, the script that we downloaded from the internet. All of the sources and versions of these things are tracked and they're modular. And now we're going to run all of them together again with the DataLad containers run command. So we have DataLad containers run and we messages compute the brain mask. That is our container that we're giving it. This is the input data. The output goes into figures and another output subject to dash. Okay, I'm not sure what that does. And then finally, the code is the script, right? So running it, it's doing some stuff. So you can see it gets the data that it needs, because it's a DataLad data set where the annex is somewhere else, in this case on Gen.
And this get brain mask. Is this on the container or is this on my?
This is, I will go back on this side. I will go back to where we got that. Here. No, but this is where we added the subdata set from Gen, and this is where we got the code. So I basically illustrated that stuff that you add to your data set doesn't always have to be another data set elsewhere or a Git repository. It can also just be a file that you could just copy and paste it into your repo and then DataLad save, or you can do something like download URL, which then fetches information from a file online and also captures the source of that edition. Now we've ran it, and we can do a git log to see what we can do. A DataLad diff, we can do a git log to inspect. With git log, you can also inspect specific files. So in this case, we do git log subject to blah, 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 brain mask, because this is the resulting file. And this is the basically the commit that is connected to that change.
Because DataLad containers run also adds and saves it.
Yes.
In there.
Yes.
Again, it just pre-package everything together and assumes that you cannot stage it yourself and then commit it yourself. It just does it automatically.
It does automatically when it comes to the compute. Sorry, the DataLad run command.
Yeah.
So in the generic sense, I say a provenance record, but in a very specific sense, it's in a DataLad sense, it's called the run command, and in a Git sense, it's the commit message. Yeah. So that is committed every time you do a run command or a DataLad run or DataLad containers run. It makes a commit.
And there's nowhere to flag away that commit.
No, but that, I mean, you could change the source code of DataLad, yeah. But the point is that is where the strength comes from, because now exactly what you did on which states of input data is captured in the Git history.
And the nice thing is now you can, if you look at the log message, see, now we can see we've used the singularity container that has the brain mask in it. We know it's actually the nylon container we used. This was the input image and the output was here. Now I want to know where did that Nifty file go? I say git log and give the name of that Nifty file.
Yeah.
And then I see, oh, we created that earlier with this bits conversion command. And that comes from this DICOM file. So this means I can I have a record and track of where did I actually come from.
Yeah, and who did it? So you can blame them if it's shitty. And then to illustrate the rerun command, you just say DataLad rerun. It will take the latest commit, or it will take as an argument the commit number or hash. Yes, sorry.
So if you make a one on the data and it doesn't go through, so it's stopping in the middle and you have an error message. And later on, if you run it again, and how does this two metadata merge? Or this git log thing merge? Would it merge, or will we just simply?
If there's an error that results in the process stopping, it wouldn't create the commit message, because that is only created once you have successfully completed the run command.
Oh, the whole thing.
Yeah.
Okay. So what about a program that has steps, motion correction and gateway something, but you only did finish the motion correction without any errors, but then you stop? Would it also create a?
Depends on if you have multiple chained run commands that do individual things. So if there was a run command that did motion correction and it works, it would have that commit message. And if this next run command is for fMRI, like, I don't know, slice time correction, and that fails, then you wouldn't have that commit message. So it also depends on how you structure the run command process. Yeah.
So literally on our file system now, we can see in the PVE lab folder, we can see motion correction happened here. We can see that, and we can see when the files changed. We can maybe even with the units trace down who the user was. We have no idea what version of error was done or how that was actually made. And that's what this one gives you the possibility to. And actually, if you follow GDPR to the law, then you should always know who touched personal data and what did they do with it.
So here you will see the Git history. So we created that data set, we applied the configuration, we added the sub data set where the source data comes from, we downloaded code, the brain mask code, and then we added the container. So all of that is captured as commit messages, and then there's a single commit message for the run command. So this might also be generating multiple outputs, right? But you have that single commit message that's related to one commit.
Okay, we have a question from Rambo.
Yes.
I can ask it if you want.
If we're trying parts of our analysis out, trying to get our scripts to run properly, finding issues, changing parameters, etc., then does it not eventually get clogged with all the files? Question mark. Or is the expectation to commit an analysis after figuring out everything out and being sure that we have the correct?
Yeah. Okay. So there's multiple options you have. Like you can manually decide when you want to commit if you don't use DataLad run or DataLad containers run, because that automatically makes a commit, right? But there's a command with DataLad, so we can say.
I suppose that ties into my question. Can you flag away the commit part? Like if
you can do it. So there's a flag called dry run. Let me just delete. Sorry, this is going to take a while because I don't have. Okay, DataLad run help. So there it gives you all the different flags, and there is a flag called dry run. And what this does is there's a very specific description down here. There. Do not run the command, just display the details about the command execution, a value of basic reports, a few important details about the execution, including expanded command, blah, 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 blah. So it's like a dry run in terms of it comes from, I don't know what industry or something, but when you prepare to do something that is supposed to be published, what's the word, in production, you can also do a dry run of it to see if everything works out as you expect it will do. So it will run the command.
This wouldn't create an output though, right?
No.
This would only create the whatever is like gonna
be input to the different stuff. Yeah.
So this we wouldn't be able to like muck around and look at input output.
But
No, so then I would then you would do it without DataLad run. So you just do it and then inspect it yourself as you would. Yeah. Yeah.
Right.
Yeah, you can just, the files are there, right? So you can, even though it's a DataLad GitHub, or the DataLad data repo, I can still just write my normal Python, MATLAB, whatever code, and run everything in there. And then only when I'm, okay, this is the analysis I actually want to do.
Then you Dockerize.
Then I Dockerize.
I think that's a question to Graham's, or answer to Graham's question here. If he wants to.
And there for the DataLad container command, there isn't a dry run option, just for the sake of clarity. Okay, so and then we can DataLad rerun. So this is also where it makes it easy to do computational reproducibility. So someone else can then clone all of this, and if they want to literally run the same analysis on their own side, they would just say DataLad rerun and point to the commit where that run command is the main message. And if you just say without commits, it takes the last run command. So there it says run commit blah blah blah, compute brain mask, and it does exactly the same. Recomputes. And then you can also see if it's like bitwise compatible. So you can say rerun and put it in a different place, and then like calculate hashes of all the data, compare it to the regional outputs, and see, okay, this is like bitwise reproducible, which is like the gold standard for reproducibility.
Then you use free server.
So that is like it's more than the basics of DataLad. It's like, I would say, comprehensive basics of DataLad. So this would allow you to do like distributed data management with colleagues everywhere and keep track of everything and feel nice about it. There's a lot more that it can do. There's a whole handbook that basically Adina created single-handedly, which is you can already get a PhD for. So there's a lot of help in the handbook. If you start using this like really intensively and you get to problems, we also have regular, what do you call it, office hours. So if you really want to help and you want to discuss stuff with the whole team and figure out stuff like how do I solve this issue, you can just contact us. We have there's a public chat room on Matrix. There's a lot of resources.